everyone, welcome to our lesson on arithmetic sequences. When we start talking about sequences, we're talking about things that are lists of numbers that form some kind of pattern. And when we talk about arithmetic sequences, that's going to be our addition patterns. So in order for us to truly be looking at an arithmetic sequence, we're going to be on the lookout for an addition pattern from one term to the next. And one requirement is that each number that we're adding has to be the same from one term to the next. So that's called the common difference. When you find the difference between your first term and your second, and then the second and the third and fourth and so on, those differences have to be the same. They have to be constant. So when you find that that is the case, then you have an arithmetic sequence. So we're going to take a look at a couple of examples of these and a couple of things you might see that are not examples so that you can know how to identify these. So on the left here we've got 1, 3, 5, 7, 9. So from 1 to 3 we have added 2. From 3 to 5 is another 2. 5 to 7 and so on. So you can see that each time we're adding the same amount to get to the next term. So therefore we have an arithmetic sequence here. And I wanted to show you that in this next sequence, we're actually taking away the same amount each time. 5 to 2 is actually adding -3. Okay, 2 down to -1 is adding another -3. And since we are adding the same amount, even though we're adding a negative value, that is still an arithmetic sequence. So it doesn't matter if you're adding a positive amount or a negative amount. As long as it's the same common difference, then we have an arithmetic sequence. You may come across some things that are tempting to call arithmetic sequences, but they're not. They are some kind of addition pattern, but they don't follow that common difference rule. Such as this top one here. 6 to 8 is an addition of 2. 8 to 11 is 3. 11 to 15 is 4. So it is forming a pattern of addition, but since that amount is not the same each time, we can't call this an arithmetic sequence. Alright, got another one down here on the non-examples. 1 down to -3. We're adding -2. -1 to -3 is adding -2. -3 to -5 is also another -2, but then you can see you got to be careful because when you hit the third or fourth term sometimes is when it changes. So always check on that. -5 to -8, that is not steady. Okay, that is -3, so it doesn't match. So we don't have an arithmetic sequence there. Alright, now that you've seen some examples and some non-examples, let's practice with these a little bit and see what you'll have to be doing with them. Sometimes you'll be asked to find the first 4 in a list, or 5 or 6, and you'll be given the rule for the sequence. And the rule is just the formula that you follow to find those terms. So here we have our rule for this particular arithmetic sequence. A sub n equals 8 plus 5n. So what you're going to do to find any given term, the n stands for the number of term that you want. So if we want to find the first 4, we are going to plug in to find the first term, we're going to plug in 1. To find the second term, we're going to plug in 2, and so on. So we're going to do this 4 times because we want the first 4. So this will give us our third. This will give us our fourth right here. Alright, so you're just going to do the math in the correct order of operations. So 8 plus 5 times 1, 8 plus 5. It's going to give us 13. And then we have 8 plus 10. It's going to give us 18. 8 plus 15 gives us 23, and then 8 plus 20, 28. So the first 4 terms in this sequence is 13, 18, 23, and 28. That's our answer. You can always go back just to make sure that you did this correctly. You can check on that common difference. So notice we're adding 5 each time, so it looks like we're good to go. We have a steady common difference there. So we have our arithmetic sequence. First 4 terms. Alright, let's say that we are given a list and they have told us that we have an arithmetic sequence and we want to form the rule for that sequence. Instead of going from a rule and finding terms, let's go from terms and make the rule. So what we're going to do is you can see here which pieces need to go in which locations. we're always going to use this formula here. A sub n equals a sub 1. A sub 1 means the first term. And then plus n minus 1. Remember, n is the number of the term that you're dealing with. And we're going to multiply that part by d, the common difference. Okay? So a sub n equals a sub 1 plus n minus 1 times d. You always want to copy that down when you're going to go form the rule. So here's our list that we would like to form a rule for. 2, 10, 18, 26, and so on. So let's work on this. Remember, a sub n equals a sub 1 plus n minus 1 times d. So we're just going to put our information into this formula and form the rule. A sub 1 we will need, that is the first term. So you can see that that's here. First thing we see in our list is 2. We will also need the d, the common difference, so we need to go to our sequence and identify that. From 2 to 10, that is increasing by 8. Let's make sure that it does that each time. Yes, 10 to 18 is 8. And another 8 here. So our common difference is 8. All right, everything else we're going to leave the same. When we make a rule, we want to leave n as n because we want to have something to plug into if we need to find additional terms. So we want to leave that n as a variable. So rewriting this, we have a sub n equals 2 plus n minus 1 times 8. Now we won't leave it like this because we can continue and simplify this a little bit and make it look a little better, a little smaller. So what we'll do is we'll distribute our 8 over here to this group. So we'll have a sub n equals 2 plus, we're going to multiply 8 times n and 8 times negative 1. And I can see a couple like terms that can go together here, my 2 and my negative 8. So simplified, we should have a sub n equals 8n minus 6. Okay, so there's our rule for the sequence. And if you'd like to test that, what you can do is plug in 1, 2, 3, or 4. We can see the first 4 terms of our sequence here. So any number that you plug in, you should arrive at that term in the sequence. For instance, if I plug in a 1, I should end up with a 2 because that is the first term in our sequence. So just test it. If I plug in a 1 here, it'd be 8 times 1, that's 8. Subtract 6, and that gives me 2. So that's a good sign. We did, and you can test any number of them that you want to. Make sure you get them to come out correctly. Alright, so now, the reason why rules are useful is because you can use them to find maybe higher numbers in the sequence. If instead of counting out, spending a lot of time counting out up to that term, we can use our rule to find it instead. So suppose we wanted to find the 50th term of this sequence that we just looked at. Okay, so we came up with a rule, a sub n equals 8n minus 6. So let's write that down. A sub n equals 8 times n minus 6. That was our rule. So if I put a 50 in for my n, that's going to give me the 50th term. So right now I'm finding a sub 50. I could insert my 50 there just to know the name of the term that I'm finding. Alright, so we're going to multiply 8 by 50. We're going to get 400 minus 6. So a sub 50, that 50th term, is 396. Alright, and this is going to conclude our lesson on arithmetic sequences.